Now we are going to compare MOSFET and JFET. So first we'll compare what is the difference between MOSFET and JFET. Okay. So MOSFET is a in MOSFET we have enhancement and depletion. In MOSFET we have enhancement and depletion type. So whatever in the metal side, whatever charge is there, you are going to have an equal and opposite charge present on the semiconductor side. So in enhancement MOSFET, we are going to bias metal with a positive gate voltage, right? So a semiconductor also will have an equal and opposite positive gate voltage. When you are going to have a metal layer to be negative voltage, it will produce negative voltage in the semiconductor also. It will produce the equal and opposite positive voltage in the semiconductor. So here in MOSFET, it is going to be based on the charge deposited on the semiconductor, which will control the conductivity of the channel. So depending on what charge is deposited, that will control the conductivity of the channel. But in JFET, it is very simple. The reverse bias PN junction diode will control the conductivity. So if you remember the diagram for JFET, in a complete N-type silicon bar, will be etching out or diffusing two P-type regions, so giving rise to two reverse bias PN junction layers. So that is going to control the conductivity of a channel in JFET, whereas in MOSFET, the whatever charge or electric field you are going to apply across the metal, oxide, and semiconductor layer, that is going to control the conductivity. In MOSFET, the leakage current is very, very low. You see, it is 1 picoamperes, in the order of picoamperes. Pico is 10 power minus 12. So the input resistance will be in the order of very, very high. When the current is almost very, very less, the resistance is very high. So 10 power minus 12 picoamperes means almost the current is zero. So the input impedance will be almost infinity, but we cannot measure infinity, right? So we quantify the input resistance of MOSFET to be very, very high in the order of 10 power 10 to 10 power 15 ohms. Okay. So it will be in the order of giga ohms. So giga ohms we have not seen so far. So you can say that the input impedance of MOSFET will be in the order of giga ohms. Whereas in the JFET, you see the leakage current is nanoamperes. So accordingly, the input resistance will be very much less compared to your MOSFET. It will be in the order of 0.1 gigaamperes. In JFET, the input impedance is 0.1 giga ohms, whereas in MOSFET, it is going to be 10 giga ohm minimum. Maximum, it is going to 10 power 15. Okay. So that is one basic difference. First difference is how the conductivity happens. In MOSFET, the conductivity happens because of the electric field set up across the metal, oxide, and semiconductor region. Whereas in JFET, the conductivity is because of the reverse biased PN junction characteristics. And leakage current characteristics in MOSFET, the leakage current is in the order of picoamperes. So the resistance will be very, very high in the order of giga ohms. Whereas in JFET, it is in the order of nanoamperes. So the input resistance will be in the order of 10 power 8 ohms or 0.1 giga ohms. The output characteristics of JFET are flatter. So as a main thing I told you, right? So when you see the drain characteristics in JFET, it is going to increase and become constant. But in MOSFET, it is going to increase and keep on increasing like this. That is what to say here. See here, the output characteristics of JFET are flatter than those of MOSFET, which means the current will increase and stay constant. But in MOSFET, the current is going to be increased and it's going to be keeping on increasing. And hence the drain resistance of JFET is very, very high because it is flat. It reaches saturation very quickly. So the drain resistance of JFET is very, very high compared to MOSFET. In MOSFET, it is not in saturation. It is still keeping on increasing, right? Only when the current becomes constant, you call it saturation. So when you have a very heavy current flowing through your device, that scenario is going to be called as saturation. In JFET achieves saturation very quickly, but MOSFET takes a longer time to achieve saturation. So that's the reason why the drain resistance of JFET is in the order of mega ohm, but it is for MOSFET it is only in the order of kilo ohms. And JFET, they are operating only in depletion mode, whereas in MOSFET, you can operate them in both enhancement and depletion mode. JFET, you don't have something called MOS layer, right? Metal oxide semiconductor. So you have only one N region and two diffuse P region. So everything depends on the biasing of your PN junctions only. That's why they say JFET are always in depletion mode, whereas MOSFET, you have the choice depending on whatever voltage you give between the uh, uh, metal and oxide layer. You can choose the mode to be enhancement mode or depletion mode. So compared to JFET, MOSFETs are very easy to fabricate, and MOSFETs are susceptible to overload voltages. Since this device is not reaching saturation very fast, this MOSFET is susceptible to overload voltage, which means if a sudden overload happens, the device cannot withstand. So when you design circuits using MOSFET, you have to make this point very, very clear and ensure that no overload is going to strike your MOSFET. And if overload strikes your MOSFET, the device will get damaged. And so you have to have the sufficient protection circuits for ensuring overload protection in your device for MOSFET, not for JFET. The MOSFET has zero offset voltage, which means you can interchange drain and source. So drain and source are identical terminals which are formed from the same type of material, N plus or P plus, right? So MOSFET has zero voltage. Zero offset means when you don't apply any voltage, output should also be zero. But what happens because of all these minority carriers and leakage current, when you don't apply any voltage, there will be some leakage current flowing. That is called as offset current. So அதே மாதிரி when you don't apply any voltage, output voltage should be zero. But because of all these minority carriers and other effects, the output voltage will be very, very small in the order of micro voltage. That has to be zero. But it will be practically existing for all devices. For MOSFET, they say it has zero offset voltage. So if you give zero input, output is strictly zero. If you give some finite input, output is finite voltage. So MOSFET is a device having zero offset voltage. So it is a symmetrical device, which means that you can interchange your source and drain. So if you wrongly connect your circuit, instead of source, you are connecting drain. Instead of drain, you are connecting your source. MOSFET will still work because these two terminals are almost same. They don't have any much difference, right? So they, for us, this terminal is going to be, we are going to say this is going to be source and this is going to be drain. But actually, when you consider the construction of the MOSFET and other device characteristics, these two terminals are going to be completely identical. Okay, they are going to be completely identical. So MOSFET is going to lead into a new set of devices called as CMOS, complementary metal oxide semiconductor devices, which are going to have almost zero power dissipation and very low voltage and current requirements. So these systems are going to be more suitable for portable systems. So MOSFET is also outdated now. So now the world is into the family of CMOS. CMOS is complementary metal oxide semiconductor field effect transistor. Complementary means if I'm using one N channel, I'll be using one P channel. N and P are complementary. Okay, in all CMOS circuits, you will see a pair of MOSFETs being used. One is N channel, another one is going to be P channel. When you combine these two things, you are going to call that as CMOS, complementary metal oxide semiconductor field effect transistor. Okay, and these CMOS circuits are very popular nowadays because they have almost zero power dissipation. The operating range for voltage and current is also going to be very, very less. So this makes them very, very advantageous for many real-time applications. And MOSFETs are widely used in digital VLSI circuits than JFETs because MOSFETs are having zero offset voltage, so they are predominantly preferred over JFET in your digital VLSI